Dark matter is often defined as one of the world's greatest scientific mysteries and something that we, as humans, still know very little about. But what is dark matter? How is it discovered? How can we learn more about this invisible mass? Though there are still questions about dark matter we don't know the answer to, scientists around the world have gathered a baseline understanding of what dark matter is and how it interacts with the universe around us. Dark matter was first discovered in 1933 when astronomer Fritz Zwicky observed a lack of mass in the Coma cluster of galaxies. Fritz Zwicky noticed that around 99% of the matter that would be necessary to prevent these galaxies from leaving each other's gravitational pull was missing. In order to fully understand this, we need to know about the science behind how a galaxy stays together. In order for a galaxy or cluster of galaxies to stay intact, there needs to be a certain amount of mass in order to produce the huge amounts of gravity that keep these systems intact. Without enough mass to produce the gravity that holds these galaxies together, they would not produce enough gravitational pull and would fly apart entirely. So, while astronomer Fritz Zwicky was observing the Coma cluster of galaxies, he noticed that there was not near enough mass within these galaxies that would be necessary to produce a gravitational pull strong enough to keep these galaxies together. These galaxies should have simply separated from each other according to astrophysics at the time. Fritz concluded that there must be some sort of invisible mass holding these galaxies together. He called this phenomenon missing mass. Sadly, Fritz was not very respected in the world of astronomy, and his new discovery was quickly dismissed as a crazy idea. After all, how could something we can't see have the strength to hold entire galaxies together? The idea of a strange invisible mass holding galaxies together was forgotten for years until astronomer Vera Rubin made a similar observation. Vera was observing the spectra of stars in the Andromeda galaxy and noticed that many stars in the outer spirals were orbiting at such high speeds they should have flown apart from each other. Vera and her team observed the rotational curve of the galaxy to be flat, which meant the outer spirals of the galaxy had to have been orbiting at the same speed as the stars close to the center. Back then, it was assumed that the further the separation between the star and the center were, the lower the orbital velocity would be. This was because there was not near enough mass towards the edges of the galaxies to keep these stars in such a high and fast orbit. The amount of visible mass within these galaxies was not near enough to hold these outer stars in their orbits. These particular stars towards the edges of the galaxies should have surpassed the galaxy's gravitational pull and flown away. Again, there had to be an invisible mass preventing these stars from exiting the galaxies. Fritz Zwicky's idea of missing mass has suddenly gripped the scientific community. In a rush to understand the lack of mass observed by both Fritz and Vera, astronomers conducted many experiments and observations in an attempt to finally prove that without a doubt there is an invisible mass holding our universe together. A discovery like this would change the way we think about the universe entirely. This brings us to the gravitational lensing effect. The gravitational lensing effect was an effect that we used to prove the existence of dark matter. This effect helped scientists calculate the amount of mass an object has by observing the light behind it and how the object's gravity bends that light. The more bent and distorted the light is, the more mass there was within that object. This idea relates directly to Einstein's general relativity. Einstein states that if we put mass between us and an object we are observing, the mass will curve space-time and will act as a lens to bend light. When astronomers observed these galaxies with gravitational lensing, the bent light told them that the amount of mass was far greater than. When comparing the results of both gravitational lensing and studying the rotational curves of galaxies, both observations show that there is somehow much more mass within these galaxies than previously expected. The existence of this missing mass is no longer questioned. However, the search for what it is still remains. The development of new technology is crucial for understanding more about this mysterious mass. With Euclid, a new ESA telescope, dark matter and dark energy will be much less of a mystery because of how Euclid gathers data and maps the sky. After being stationed 1.5 million kilometers from Earth, this new telescope will map a third of the sky while also being programmed to observe and gather information using gravitational lensing. This will give us a much bigger picture of how much dark matter there is and how systems coincide with it. Even in the modern world of astronomy that we live in today, the mystery of dark matter still remains. Scientists all over the world are working to learn more about this invisible mass, and new observations are being brought to light more often than ever. For example, a study conducted in 2006 that scientists say proves the undeniable existence of dark matter. This study consisted of a group of astronomers studying the Bullet Galaxy Cluster, which is a product of a collision between two large galaxy clusters. The collision between these two galaxy clusters is considered the most energetic cosmic event besides the Big Bang that we know about. The scientists looked at the collision of these two galaxy clusters and studied where all the mass ended up after the collision using gravitational lensing. They noticed that all of the gases within these galaxies were slowed down by something very similar to air resistance, while the dark matter was not slowed by the impact whatsoever. The reason the dark matter did not experience this resistance during the collision is because dark matter only interacts with matter through gravity. This produced the separation of dark matter and normal matter as seen in the scientists' data. After analyzing their findings, the astronomers working on the Bullet Galaxy Cluster study concluded without a doubt that dark matter is a fundamental part of the universe. In combination of recent studies such as this and old observations such as the ones made by Fritz and Vera, dark matter is not only all around us but is a crucial part of our universe. Here is a simulation of the distribution of dark matter, made and rendered by a supercomputer. As you can see, modern astronomy and technology have allowed us to create a picture of how much dark matter there really is. Dark matter makes up the majority of our universe, yet it is completely invisible to us. Thanks to the early observations made by both Fritz Zwicky and Vera Rubin, and the more recent studies such as the NASA Bullet Galaxy Cluster study, scientists are now able to deduce that around 85% of the mass in the observable universe is dark matter and dark energy. The remaining 15% is the matter we see each and every day. A hidden mass that neither reacts with itself or light, dark matter is truly one of the biggest mysteries to the scientific world. We still have a lot to learn about the universe, and new discoveries such as the discovery of dark matter completely change what we once thought we knew. Dark matter teaches us that we are still in our infant stages of understanding the universe and our place in it.